So first of all, thank you so much for coming. I'm aware I think it's Josh Long who's presenting, so I'm very thankful you've come to see me talk. I hope this will be helpful. So it's Istio platform versus Spring and MicroProfile frameworks. So a nice exciting title. You might have seen on social media or online that I was supposed to have my colleague Adam here with me today. Unfortunately, Adam has not been able to make it. So I work for IBM on a product called IBM Event Streams, which is Kafka on Kubernetes on-prem on IBM Cloud. And unfortunately, he's had to stay back at the office and continue working on IBM Event Streams. So it's just me that have come today. So I'm going to talk about these three things today. So I'm going to start with a software development evolution, try and set the scene for where Istio has come from, the reasons behind it, and then that will inform some of the later parts of the session. I'll give an introduction to Istio. So just hands up, who here went to, I think there was an Istio talk earlier today or yesterday? A few people. Okay, I'm not going to go into a huge amount of depth of what it does and how it does it, but just an overview of what it does and why you might want to consider it versus your frameworks. And then, of course, we'll go into the question of platform versus framework. So first of all, why go over the history? Well, some of you might have seen in a recent Stack Overflow survey about developers that actually a lot of developers have only been in this industry for less than 5 years. And that is actually true for myself. I joined IBM 4 years ago as a software engineer. And that means that actually for software engineers that have been around for a shorter amount of time, what they've seen is these recent platforms. So an explosion of things like Kubernetes, Istio, promising to deliver all of these great things as part of the platform. But if you've been around in software engineering a lot longer, and this is where having Adam with me helps because he has seen the rise of established frameworks. So this is things like Spring, Java EE. And so if you are more familiar with these established frameworks, you might feel that those are what you want to stick with, whereas if you're new, then perhaps you've only seen these recent platforms, you don't know as much about the established frameworks. But actually, we're starting to see this overlap. So it's no longer good enough to just have the people in your organization who know about the framework and the people in your organization that know about the platform. Actually, you need to have a combined effort and understand both sides of the story. And we'll see how this comes into being with Istio and Spring and MicroProfile later on. So how have we got to this situation where we've got this overlap? Well, for cloud-native applications, and this history is quite sort of high level, not necessarily completely chronological, but just to give you a flavor, it all started with the monolith. So we had our monoliths, we were quite happy scaling up to multiple versions of them, and then the cloud came along. Everyone said, okay, we've got this cloud, now we need to start using the cloud in some way. So the first thing we did is we put the monolith in the cloud. And initially, maybe that was okay, but then 12-factor came along, and we started talking about, well, what happens if something goes down? I want to replace it. Do I really want to scale up my whole monolith now that I'm really paying for exactly what I'm using? And so then that came to people going, actually, let's do microservices. Everyone is doing microservices. That's what we should do, and that will solve our problems. So you separate your microservice out into different services, and you spread them out across the cloud. And also, of course, this is containerized. So you've got all of these containerized services running in your cloud, potentially running in different clouds maybe. And that's all great, and we think, perfect. Microservices, and obviously the topic of this whole conference, that solves all of our problems. But all of the talks that I give about microservices, I always start by saying, microservices is not a silver bullet, and it will not solve all your problems. And I think we've all probably experienced that. So this is the reality. We've got some services running in the cloud. Perhaps we've got another service over here. And actually, if you want to make a call to this service, it's quicker to walk there, really. And this service over here, we're not really sure where that went. It's not responding. Maybe it just fell off the edge of the world, not really sure. So there's a few problems that are brought in when you're moving across these microservices. And that brings in actually having new patterns, but for old problems. So this idea of containers is isolation, one asset that you pass through your pipeline. But there's a lot of problems coming around, of course, the fallacies of distributed computing that you need to solve. What happens once you've deployed it? How do you make sure it continues to run? What do you do about all of these buzzwords that I've put up here? Do you know what they mean? And how do you even implement a circuit breaker or a bulkhead? So Kubernetes came along and said, well, I can solve some of these problems. It provides orchestration, helps you to stand up the number of containers that you were looking for. It has self-healing, so if one of your pods were to die, it will stand it back up again for you, so that's great. So that gives you your availability. And then, of course, scaling. It's actually fairly straightforward to go and update your YAML file and say, I want 5 versions of my application, not 3. And Kubernetes will handle that for you. And it's done through some of these terms we've got here. So you have a deployment that manages all your containers that are separated into pods. So we have Kubernetes that's providing us some capabilities. But there are potentially some other things that aren't quite provided through Kubernetes, or perhaps the framework's just thought, well, we have other ways to do it. And of course, this is where the chronological piece doesn't quite happen. So at the time leading up to and sort of overlapping with Kubernetes, the frameworks were starting to move and to do things. So one of them is Spring. So hopefully you've all heard of the Netflix OSS stack. So it includes Hystrix, Ribbon, Eureka. So this is for service discovery. You can stand up your Eureka service. That will then hold a list of where all of your applications are. You can use Hystrix and Ribbon for load balancing and circuit breaking. And Spring also has this idea of actuators, which is the health endpoint, and Spring security as well. So Spring has a whole bunch of things that you can use to easily talk to your microservices, configure them, and start to answer some of these questions around fault tolerance, load balancing, service discovery. And then, of course, hopefully some of you are aware we have MicroProfile. Hands up, who's heard of MicroProfile? Yes? No? Few people? So MicroProfile is a community-led initiative to bring in some of these and address some of these problems with microservices as part of what was Java EE, now Jakarta EE. So initially when it released, I can't remember when it was, a couple of years ago now I think, it was just bringing together some existing Java EE specifications, and a set of different vendors implemented them. So there's a whole set of different vendors. If you go over to the Eclipse booth they've got here, they've got a lovely t-shirt that you can get that has all of the vendors on the back. But over then the next couple of years, we've built up a whole set. And so some of these are existing specifications, some of them are new, and some of them are actually starting to be added into what is now Jakarta EE as well. So you can see some of the nice buzzwords up here: fault tolerance, open tracing. Again, there's the health check, JWT, which is security. So the MicroProfile community came together and said, well, we need to answer some of these questions around how do I solve my microservice problems. So we have Kubernetes and we've got MicroProfile and Spring, all sort of in the same space. But the framework support provides a few issues. So the first one being, you have the same code repeated everywhere. If I have 50 different applications running, and they're slightly different applications, but they're all running on top of Spring or on top of MicroProfile, I have to then re-implement my circuit breaking, fallbacks, etc. And what if you want different languages? So I've given 2 examples here, and today this session will be focused on Spring and MicroProfile, but of course Java isn't the only language out there. There are plenty of others you could implement your microservices in. And one of the nice things about microservices is polyglot is definitely very easy to do. But if you have different languages, you then have to work out what are the libraries I'm going to use for JavaScript, for Python, for Go, whatever that is. And there's a big support overhead. And Kubernetes doesn't solve all of the problems that the frameworks were adding on top. So Kubernetes will help you to stand up your application, but it doesn't necessarily tell your application what to do if it tries to call an endpoint and the endpoint's not there. It doesn't handle retries, circuit breakers, that kind of thing. But what if this could be handled at the platform level? And that's the question that Istio was then looking to answer. So for those of you not aware, Istio is an open platform to connect and manage and secure your microservices. So it's a service mesh. That's the sort of general definition for it. It sits on top of things like Kubernetes, and it provides intelligent routing, load balancing, fault tolerance, policy enforcement, metrics logging, service identity, and security. So a whole laundry list of lovely things to help you with your microservice environment. And so it looks like it just solves all of your problems. And I said I wasn't going to go into the in-depth architecture, but just to give you an idea so you can see where the overlaps come from. This is how the vague architecture works. So you're running in Kubernetes, which means you have your pods. Pods might have one or more containers in them, and then multiple different pods make up a service, and a service then provides load balancing between the pods. So on each side here, service A will have pods, and each of those pods are identical, and each of the ones in service B, those pods are identical. And what Istio does is it adds an extra container into your pod. So normally you would just run with your one application. You might have other containers that are tightly coupled that are running in there, but typically it's just the one. With Istio, you add an extra container to your pod and a control plane. And so this is really how it works, and Envoy is the key piece here. So your Envoy, which is your extra container that you add in, that will help provide load balancing, circuit breaking, etc. And the reason it does this is because the application, whenever it tries to make a request out, it will go via Envoy. So Envoy can do things like upgrading the security on the request. It can decide whether to retry that request, whether to just actually return and fail fast. And of course, at the bottom there, it can add some fault injection as well. So this is the really powerful thing about Istio, is it's intercepting all of this traffic, and that gives it a lot of power. Okay, so I'm just going to have a little look at some code so we can start to get a feel for what we've got with Istio versus these frameworks. There we go. So earlier I generated some applications just using our IBM Cloud generator. You can use your generator of choice. And you can see that there's a whole host of things that you might want to have when you first start generating or writing an application. So you can see, for example, this one's a Spring one. I've got health endpoint, which of course uses the Spring Boot health actuator, where I can start doing more custom health pieces. I've got some charts. So these are my Helm and Kubernetes pieces through here. Got, for example, a deployment, which is one of the Kubernetes building blocks. And again, similarly, for MicroProfile, I've got my health endpoint here. I'm not sure why it hasn't resolved that, but that is actually using, that's just a generic health endpoint, but you might be aware MicroProfile, by default, when you start your app up, it will have a health endpoint. So actually, this version of that would have two health endpoints because I've added this one in. And you can see as well, we've got Istio YAML here. So this is a slightly older version. Root rule is being deprecated, but I have a newer version here. So this is virtual service. And for Istio, for all of the pieces where we've got this circuit breaking, this retrying, this adding injection, and injecting fault, into the system, I provide it all as part of a YAML file. So it sits really nicely with Kubernetes. I just configure some YAML, and off I go. So at the moment, here we've got a mismatch of, I've got a bunch of code that helps to deploy, I've got some stuff in my app, and I have to start thinking about where do I put what? Because as a developer, this all would sit in the same repository. So I do need to have a think about how am I going to keep these separate, because although the YAML and everything sits here in my repository, I can update the YAML and my Kubernetes deployments a lot more quickly than I can probably roll out a new version of the app. So we have to start thinking about that as we go through. So let's take a deeper look, and we're going to start with service discovery. So for your service discovery, you always need to, whenever you're running microservices, you need to not use a specific endpoint. So for example here, I don't necessarily know where this application is running. Traditionally, you would do this with a server and a list of registered services, and then you would have your client communicates with the server and handles the load balancing of who it's going to call next. And this is how this works normally when you're running from a framework point of view. So you've got your service registry here, and you've got your two applications. And in your application, you can add some code. So this is an example for Spring. You can do it equally in MicroProfile, and it just says enable Eureka client, and that tells your application, actually, I want to start using Eureka, and that would be my service registry to communicate. So the application will register with service registry, and then at the point in time where one application wants to call another one, it will go to the service registry, look up where it is, and then invoke it. And that sort of works quite happily, but the key thing here is the application chooses which service to invoke. So when I've called the registry, I've got a whole list of different services back, and the app can take a choice of which version it's going to choose, and that might be at random, or it might be some extra configuration in there that says, if my username is Kate, I'm always going to use version 2. If it's anybody else, I'm going to use version 1. And the application is completely in control of that. So in contrast, let's look at Kubernetes for the starting point, because Istio is built on top of things like Kubernetes. So we have all of our pods, we have our apps, and I said in the Istio discussion earlier that in Kubernetes you have your service, and you would call that to then invoke pods. And that's exactly what happens. So my pod over here wants to call one of the versions of my application. It calls out to the app service. It does that using a DNS lookup. So it just calls out to a known name, and Kubernetes will route it for you. And then it will route to one of these applications. And the default here would just be a round robin, go one then the other. So Kubernetes is handling the load balancing. The application doesn't know that there's multiple versions. There could be 1, there could be 50. The application would have no way to tell because it's never given an explicit list of what's actually running. So how does this work in Istio? Well, I said Istio, you can provide routing policies on top of your existing YAML. So in this case, the pod will call out to the app service, and then Istio will get involved and say, I know from my routing policy that you have to call version 1. Not version 2. So here again, the application doesn't know what's happening. It doesn't know that there's a version 2 it could be called. It's just having Istio enforce all of the policies that are required here. So we have these two fairly different approaches. But what happens if you run them all at once? So say I've got my application, I've already got my Eureka, and I've got some Istio setup environment that I'm going to deploy into, and I just say, well, I'll throw them all together. There's a few different ways you could do this. So say in Eureka we've got a list of all the app services we're running in Kubernetes. That would make sense. So my application calls out to Eureka saying, please can I get the service list of everything that's available? It has to call Eureka service to get to its Eureka, which is a little bit odd. Service discovery for your service discovery. But regardless, you get hold of the list of app services, and that's fine. And this list will say, we've got version 1, and here's where the service is. Version 2, here's where the service is. So then the app says, OK, I'm going to call out to app version 1. But then Istio can get involved and say, well, you said you were calling through to this app service, but actually under the covers I'm going to call version 2. And because this app service is backing both of them, you get into a situation where the application thought it was calling version 1, but it's actually not. And there's no way for that app to know that it actually was routed through to version 2, really. So this isn't the best scenario because, of course, it means that as the app developer, you're not getting the behavior that you were expecting. But for the person who's maintaining the system and who's enforced those policies in Istio, that they're completely happy. So what if we do it a different way? What if we actually put in the specific IP addresses of these different pods? Now that's not the best thing to do in Kubernetes anyway, because the idea is you're not supposed to have specific endpoints, but you can find out the specific IP. So say we do that instead, and the app goes to find the service list, and then it calls it. So that seems much better, if you're the app developer, of course, because now you've called through to the app that you wanted. But if you're the person who's maintaining the policies in Istio, you say, well, actually, my policy hasn't been enforced. So why did I write that piece of YAML to enforce it? So really here, we don't have the best solution either ways. Now, there is work being done in this area. So for Spring, there's a Spring Cloud Kubernetes module that's being worked on, and that includes sort of integrations with Zipkin and Ribbon, and basically what that's trying to do is make your Spring Boot app work nicer with things like Kubernetes and Istio. But really, when it comes to service discovery, you do need to make a choice of, am I going to let the app make the decision of who I'm going to call, or am I going to leave it down to the platform? Oh, I should mention as well, I haven't put it on the slide, but the team in MicroProfile do have a working project as well to do similar things to the Spring Cloud Kubernetes stuff with MicroProfile. They're not specifically looking at service discovery, though, just because for MicroProfile that kind of came along once Kubernetes was getting started, so there aren't that many people, I don't think, using Netflix OSS. With MicroProfile, it tends to be a Spring-related thing. So what about fault tolerance? One of the key advantages of moving to microservices is that you have applications that are supposed to be more resilient. And the way that you have this is because you've got all these different parts of your application that are deployed independently, and if one of them goes down, if you've written your microservice well, that shouldn't take down the whole thing. So you can imagine in a scenario where if you've got, say, the BBC website, so a news website, if it has lots of recommendations on one side, you could imagine that if that part wasn't working, you wouldn't want to not display the whole page. So if that app went down, you would want to put something in place so that you could still display the rest of the page just without that recommendation service. So that's what you want from fault tolerance. So we have some framework support again, Netflix Hystrix being the one that I already mentioned, and MicroProfile have a fault tolerance module that you can use to configure circuit breakers and all of the kind of normal fault tolerance things you would expect. And here again, the behavior is being specified per app. So when you write your application code, you're making a choice around specifically, how many retries am I going to do, when am I going to trip the circuit, and the other one is the fallback behavior. So it's not enough to say, I'm going to put in a circuit breaker. You then have to decide if the circuit trips and fallback gets called, what actually happens. You could display a big thing on the page saying, everything's broken, but maybe that's not the best fallback behavior. So your app has the behavior really built into it here. So for Istio, it's built into the infrastructure. So again, here you provide a YAML file that says these are the number of retries I want to have. And this can be per sort of service request. You can say when this one's calling this one, this service to this service, that's how many retries I want. And you have almost no code in the app. And the advantage here is that you have fault injection. So because I mentioned earlier we had the envoy sitting there nicely and interrupting all of the traffic, you could actually run a test on your staging system or really on your production system where you could say, let's see what happens if we pretend this service over here is down. And we just return saying there's been an error. And the nice thing about that is you haven't had to really take down the system. So say you suddenly got a peak in the number of people visiting your site or using your application, you could quickly just remove that policy and have everything working again. So it's a really nice way to test out the fault tolerance within your system. Now, I said there is no code in the app, almost. Well, the piece that you don't have from Istio is that fallback behavior. So Istio will quite happily do retries, it will put in a circuit breaker, but your app still has to do something when a response comes back. So you can't move completely to Istio and forget to deal with the breaking situations. It doesn't quite solve all of your problems, unfortunately. So what happens if you do it combined? There's two different things to think about here. One of them is circuit breaking related and one of them is retry related. So if we think this through, if I've got my application running here and I've got Istio running, and in my application I configure it to say, actually, I am going to try 4 times, and if on the 4, if there's 4 different requests and they all don't go through, then I'm going to fail fast and I'm going to say I'm not going to bother actually making the call out anymore. And that's something you can do with Spring and with MicroProfile. So we've got this situation here. Say we do that in Istio as well, but in Istio, we say we're actually going to do it 3 times. So then what you could have is the app makes a request, Istio forwards it on, request fails, comes all the way back. Okay, that's fine, we'll carry on. Later, we'll make another request. That's the second one, that goes through fine. Third request goes through, it fails. Istio says, okay, I'm closing the circuit now, or opening the circuit rather. At that point, when the application makes the 4th request, Istio won't actually make the request through, it will just return saying, no, that failed. So maybe that's not too much of a big deal, but it does mean that now your app is getting a response and saying, oh, that actually failed, when it could be that what's actually happened is Istio is the one that said it's failed and it actually hasn't propagated the request through. So you start to get a bit of tension between what Istio is trying to do and what the application is trying to do. And again here, it really is the application that is in the dark all of the time, because the application has no clue that Istio is doing all of this circuit breaking. But I think the more interesting one is for the retries. Because until you start to think about it, you don't realize how quickly this could get out of hand. Because if I'm configured to make 3 retries from my application, but I also configure Istio to make 3 retries, then the flow would be my app makes a request, Istio makes a request, the application on the end say it's not there, it fails. Istio says, okay, I'm going to retry. Okay, that failed, I'll retry one more time. Okay, that failed, pass it back to the app. Then the app says, okay, I'll do my second retry. Off I go. Istio tries. Oh, it failed. I'll try again. Oh, it failed. I'll try again. Okay, now it's failed. Back to the app. And then the app says, right, I'm ready for retry number 3. You can see this is just for 3 and 3. You already get 9 then retries. It could get quite out of hand quite quickly. So if you're configuring circuit breakers, retries, or any kind of fault tolerance, you really want to be doing it either in your app or in Istio. Do try not to get in a situation where you're doing it in both places, because you will see some very interesting stuff going on here. So the key thing is you need to understand the flow of your request and know this is what I want to happen and this is how I make it happen. So you really need to have good communication between whoever's writing the application and whoever's writing that Istio YAML. And if you keep it all in one repository, hopefully that communication will be fairly easy. But you can update your Kubernetes and your Istio YAML while it's in production. So what you need to watch is your application developers writing, sending up, potentially, hopefully because you're running full stack microservices, they're also maintaining it. But what you want to watch is someone coming along who doesn't really understand what the app is doing and going, I'll just add some more retries in there because something was failing, without understanding that the app's already handling that behavior. So now we have security. So we talked about service discovery and some of the different pieces there. We talked about fault tolerance as well. When it comes to security, so this is a picture back from 2017. That's Adam, in case you're wondering. We like giving talks together. So we gave a talk about securing microservices. You can go look it up if you want to. But we had 3 specific points. And we said the key aims when you're securing microservices is you want to understand who is the person making the request, because that probably makes a difference of what they're allowed to do. Do I trust them? So that's, do I trust the service that's made the request to me? And has anything changed? So has anything changed while this request is propagated through my system? And there are a few different things that are available as part of the framework and the Istio support. So if any of these terms are unfamiliar to you, feel free to go and look up that video and have a look through it. And we go into a lot of depth of what a JSON Web Token is and what a HMAC is and all of that. So in the framework, we have Spring Security and we have MicroProfile JWT authentication. So a JWT is for a representation of a user trying to make a request. And this provides you with mechanisms for MicroProfile. It's propagating that JWT through your system. Spring Security also provides a few different pieces in this area. And again, you can see a little bit of a theme here. The code is built into your application itself. And then the Istio support that we have did look a little bit like this. So we had mutual TLS. So Istio will actually, because it's got Envoy there, as the request goes out through Envoy, it will upgrade your request and run mutual TLS between the services. It also has service-to-service encryption, and it's all administered by policy. And that's really nice because I can say this service A is only allowed to call service B. It's not allowed to call anything else. And that means that if something did happen and someone managed to hijack your service A, it does help to sort of restrict perhaps the damage that can be done within your system. And it starts to build up enforceable ways that things will interact. So actually, if you want to say, we want to keep our topology of who's calling who fairly simple, you could put in all of these policies to say, this is really the only person you should be calling. So it's quite a nice feature. And all of this is very service-centric. So Istio is relatively new as it's built up. A lot of what they've been putting in is around one service in Istio talking to another service in Istio, and not necessarily what happens outside your nice sphere of everything being in Istio. Whereas the MicroProfile and Spring Security start to deal with a bit of more end-user authentication. So this could then be linked across to who are you, has anything changed, and that's how you then can authenticate and make sure you know whether someone who's trying to make a request is really allowed to do what they're planning to do. And then, of course, has anything changed? That comes in with being able to share secrets and sort of understand, am I really feeling safe between these services? And so then Istio has the do I trust you? So that's the service to service. Do I understand that the service I'm talking to is another part of my Istio system? And actually, if both the apps are running in Istio, it's quite easy for the people developing Istio to place things in so that you can make sure everyone in that Istio mesh is a good citizen. But you might, if you have looked at all at what Istio have been up to, the last time I gave this talk was back in March, this wasn't available. But now, they actually have started looking at end-user authentication. So there isn't anything within Istio, or actually I don't think within MicroProfile or Spring explicitly, that will create a JSON Web Token for you. There are some nice Java libraries out there that you can just happily use. But what they have recently added into Istio is Istio will do some of the JWT authentication for you. So you can say things like, if my JWT has come from Google, then I want to trust it. And you can get it to validate that it really is a JWT that you're expecting. So they've actually started moving into the realm of who are you and has anything changed, because you can use the JWT if you sign it to verify nothing has changed over the wire. So this leaves us with an interesting situation when it actually comes to security, because on the one hand, Istio is expanding the field of influence of what they're doing with security. And you can do a lot of your security pieces within Istio now. But on the other hand, if you look at the framework support, you could argue that really your application is the one that should know whether a particular service is allowed to do something, whether a particular user is allowed to do something. So there really is conflicting pieces on either side here, and it's not necessarily as straightforward as I'll turn it on in Istio or I'll turn it on in MicroProfile, because they do provide slightly different things. So none of the framework support will give you service-to-service encryption necessarily by default. So I think the best thing to do is to potentially start to look at Istio and use that as the base for sort of general service-to-service security within your systems. But then for your individual services, have a look at what's available through MicroProfile JWT and everything, and see if there's pieces there that you want to use to sort of augment your security story. The one thing I think, though, that you will have to keep relying on your framework for is propagating security identity. So that's what the JWT is used for. It's to understand the identity. And I believe it's not quite there in MicroProfile yet. I'm not sure about Spring. But soon they'll be able to propagate a JWT through the system. So the idea is when you pass it in at the front door, you can pass it between the services and they can use it downstream. So you really do need to set up your security so your framework and Istio will work nicely together, because Istio is looking for specific things. So if you set up your application in a way that doesn't work with what Istio is trying to do, you will not quite be as secure as you're thinking, or perhaps too secure and you won't be able to do anything. Okay, so the final one is trace, logging, and metrics. So framework support, we have the Spring actuator. I showed you that earlier. And for MicroProfile, they've got a few different things: health check, metrics, and open tracing. I think the Spring actuator has some other pieces in there, but MicroProfile, they name them all separately. And these will come as default when you generate a MicroProfile or a Spring application. When you get started, these are just ready for you to use. And Istio, because it has Envoy again, intercepts all of the network traffic and can generate you a really nice service graph, which looks a little bit like this. So this is one that you can generate, and actually you don't have to do very much to get this to generate really nicely. So where does this leave your application framework, and where does this leave Istio? So Istio can handle who is calling who within your system, and actually if you want to get a really good understanding of all of the network within your platform, it makes complete sense to rely on your platform to give you that information and to help you trace requests through the system. Because otherwise you might end up with having to build this sort of custom way of implementing it all, that then you have to work out how to do it in multiple different languages and all of those problems I mentioned earlier with the frameworks. So actually having that given to Istio works really well. And it gives you nice, you can look at response times and that sort of thing. But there are some things it won't give you. So again, you have to think about how your application integrates with Istio and whether there are any pieces. So for example, with the tracing, whether you need to have an ID that you're passing through your application and out the other end to help with that distributed tracing. But also, Istio doesn't know the insides of how your app works. So I mentioned this actually earlier in the talk I gave on Kafka and Kubernetes. Kubernetes has liveness and readiness as two options you can set to say my app is ready and healthy. You need to have your application be providing the right things in order to enable all of these tracing pieces. So specifically logging to a central system. You're running in containers. If your container goes down, you don't want to lose your logs. And you should be relying on your platform to provide you things like Prometheus and Grafana to visualize what's going on in your logs. But you do need to make sure your applications are logging. And I think logging goes along with sort of testing and security and the whole other list of things that people just do at the end. And they go, oh, I think we need to debug something. Did we add any log to our code? Maybe we didn't. And so you do need to think about that up front. But the important thing is that you send all of the logs to the central place of your platform so that then you can look at it later. So I think this is how it really splits down for trace logging and metrics, in my opinion anyway. So as a summary, we have some overlapping capabilities. We talked about service discovery, we talked about fault tolerance, security, and then of course trace logging and metrics. The key thing to take away here is don't just throw it all in and assume it will work. Initially, it might look like it's going to work, but you will see some pretty interesting behavior happening if you're not careful. But actually, the general trend we're seeing is that when you use your framework, it's your application that is making a choice about what it wants to do. When you're using the platform, obviously the platform is making that choice for you. So the actual question that you need to ask yourself is, does my application have some knowledge that the platform doesn't have, but that knowledge is also required to make my decision. And if the answer is no, if the platform actually does have all of the information you need for service discovery, for fault tolerance, etc., then it's probably worth relying on the platform to do it. But there probably will be scenarios where you go, actually, the application knows about this specific thing, and for that reason, I want the application to make the decision. So it is a trade-off, and you do have to think about it. Unfortunately, it's not as easy as Istio solves all your problems in the same way it isn't with microservices. So thank you very much. I've got some links here. So if you want to learn more about Istio and all of the capabilities it have and how it actually works under the covers, you can go to istio.io. So this, I put it at the end, this is the link for the MicroProfile service mesh. If you're interested in helping the MicroProfile team look at how they integrate with Istio, then feel free to join them on that. And of course, Spring Cloud Kubernetes. And if you're interested in what I work on IBM Event Streams, which is a Kafka Kubernetes offering. So thank you very much. I think we have about 4 minutes for questions if anybody wants to ask them, or if not, you can always come up and ask me at the end. Yeah? Yes, so the question was around service discovery and what different options are available. For Istio, I think often it relies more on, I don't know if they have a separate service discovery piece, but certainly if you're running with just Kubernetes, you can rely on using their DNS lookup. So to a certain amount, it means you're not actually having to go and get a list of what services are available. You can just call a known endpoint and Kubernetes will do the routing for you. And so that's what I've seen most people using from at least a Kubernetes point of view. Then when it comes obviously to Eureka, you're then having to deploy that yourself. I think generally, if you're going to be using Istio or Kubernetes, like I said earlier, and Eureka, you probably want to be turning off any service discovery pieces and just do it through Eureka. But broadly, I think unless you're already very sort of wedded to Eureka, you can probably rely on the platform a lot for service discovery, in my opinion. And part of the reason I say that is because the Spring annotations for Eureka are really lightweight, which means they're quite lightweight to remove from your code. So my personal opinion is that actually service discovery, discovering where the services are in the system, is something that is most sensibly handled by the platform. And so if you can start removing that from your application code, it's probably something you don't need to worry about. And I'm not sure there's that many scenarios where you would say within your app, I really want this specific version. I think you could normally handle that at a slightly wider level. Okay? Any more questions? Okay, I'll be here a little bit at the end if you want to come up and ask questions. So thank you very much.